places, worn out faces, bright and early for the daily races, going nowhere, going nowhere. Their tears are filling up their glasses, no expression, no expression. Hide my head, I wanna drown my sorrow. No tomorrow, no tomorrow. And I find it kinda funny, I find it kinda sad. The dreams in which I'm dying are the best I've ever had. I find it hard to tell you, I find it hard to take. When people run in circles, it's a very, very mad world. Mad world. Children waiting for the day they feel good. Happy birthday, happy birthday. And I feel the way that every child should sit and listen, sit and listen. Went to school and I was very nervous. No one knew me, no one knew me. Hello teacher, tell me what's my lesson. Look right through me, look right through me. And I find it kind of funny, I find it kind of sad. The dreams in which I'm dying are the best I've ever had. I find it hard to tell you, I find it hard to take. People run in circles, it's a very, very mad world. Mad world.
X marks the snot again. This bugger's going to go right across. They're just preparing for the next batch of shitty weather.
Few branches of science divide opinion as sharply as that championed by
I think it's coming
Professor
through the
David
weekend.
Keith. He's one of the preeminent geoengineers, striving to find new ways to combat global warming.
They're not going to stop
by
now.
the way the
They've
sea,
been working
the
on this for
clouds,
years.
and the atmosphere work. This isn't a replacement, he says, for the political drive to reduce emissions.
They're achieving their goals.
Geoengineering, a cost-effective emergency stopgap before the effects of climate change become
There's
irreversible.
one below him as well. I'll show
A
you.
dangerous leap into the unknown.
Yeah, down there.
Professor David Keith, welcome to Hard Talk.
Thank you, great to be here.
Thank you very much for being here. Let's
Follow
start
it in
with
as we
the
go
start.
along.
What is geoengineering?
It's really two very different things which have come under the same name but have very little relationship to each other. One is ways that we would alter the amount of sunlight the Earth absorbs and so cool the planet, partly offsetting the effects of carbon in the atmosphere, and that's called solar radiation management, or in some technocratic way, SRM. And the other one is to take carbon out of the atmosphere, so-called carbon dioxide removal.
So it's both reducing emissions or dealing with the growth in emissions by taking the carbon dioxide out of the atmosphere, but it's also trying to prevent those emissions getting to us in the first place.
I'd say the thing that really is unusual and rightly scary is the idea that we can directly alter the climate by reflecting away some more sunlight. And that's scary because we have extraordinary leverage as humans. Our science technology, for better or for worse, is brand new. So with very tiny amounts of money or effort,
Bloody things
we
are
could
everywhere.
alter the
Anyway,
climate by putting these reflective particles, say, in the stratosphere. And that has profound implications, right up to big geopolitical implications.
Let me, before we get on to solar radiation management, let me ask you about the carbon dioxide removal. A Royal Society report here in the United Kingdom back in 2009 said that no method of carbon dioxide removal has yet been demonstrated to be effective
No, tried it,
at an affordable cost with acceptable environmental impacts. And they only work to reduce temperatures over very long timescales. It doesn't sound as if at the moment it's feasible.
Yeah,
I think that's exactly right, and I can say that both as an author of that report and as somebody running a startup company trying to capture CO2 from
all
the air.
these trails are
So
now
it's
spreading out.
true that anything you do either to reduce emissions, which we must do
one
if we
come
want
up
to
through
avoid
here.
climate risk, that's we must cut emissions around, or to take CO2 out of the air, inherently acts slowly because CO2 builds up in the atmosphere over centuries. It's a long time scale.
So how far are we away from some sort of technology which could do this in a way that is effective, is not too expensive, will work in a way that can be rolled out across the planet?
So technologies for removing CO2 from the air, in this case I've got to speak as somebody running a small company doing that. I think there are small niche markets where I and some of my competitors might succeed soon, but I think I view our job as trying to build a tool which humanity may or may not use over the next half century. I don't expect to see really big
You can
applications.
see all these trails.
In that case, do you think
out,
it is more exciting, this
making a lot of
other
cloud,
idea of solar
low and high.
radiation management, where you try and in some way reflect the
What a
sun's
shadow on that
rays
one.
away from planet Earth?
There's another
Exciting,
one.
I guess, is the word. I mean, it certainly
Oh, just sitting
presents more
where'd he go?
immediate security challenges and governance challenges in a way that's very
He's in that
different.
cloud there somewhere. He'll be
Well,
out
I
in a
want to
minute.
come on to this, but I want to explore first of all the science of it in terms of how it can work, whether it's
There he
feasible,
is.
how much it costs. Is SRM, solar radiation management, the path which looks as if it's more viable at the moment?
No, I think it's impossible to say which is better. The fact is they're both different tools that we need to try and manage the overall climate risk, just as is cutting emissions. And there's no way to say that one is better. They do different things in the climate system in different ways.
Explain to me, first of all, though, before we get into the pros and cons of it, how solar radiation management might work.
So conceptually,
What's going over that way? Look.
the Earth is in some kind of balance where we
Right
absorb
behind
sunlight
him.
and we radiate it away as infrared. And what CO2 is doing by warming the climate is making it harder for that infrared to get out.
A lot of
If
piles
you,
coming up behind each other. They love
reflect
that.
away a little more sunlight by adding reflective aerosols, tiny particles, say, to the upper atmosphere.
And how do you do that?
You could do it with aircraft, for example. Doing it is probably not the hard part. You could use aircraft or other methods to deliver literally tons or millions of tons of very small particles to the upper atmosphere. One
By
way,
sort of spraying them out at a high altitude.
correct. And one thing this does is to mimic what volcanoes do, at least in some crude way. So large volcanoes put sulfur into the upper atmosphere and those cool the planet.
Again, this Royal Society report that came out in 2009 did suggest that although this type of management might be, solar radiation management might be relatively cheap to deploy and simple in the way that you've described it, there are considerable uncertainties, I'm quoting from the report, about their regional consequences, and they only reduce some but not all of the effects of climate change while possibly creating other problems. How far do you recognise that?
Oh, I think that's absolutely correct, and indeed I've spent a lot of time trying to look at the environmental problems that it will create and the social problems. So, I mean, it's completely clear that you cannot perfectly compensate for the environmental effects of CO2 in the atmosphere by cutting sunlight. You may, and we haven't even proved that, be able to reduce some risks of CO2 in the air by this method.
Isn't there a problem, though, that you could end up with different effects in different parts of the world? I mean, you could, for example, find that although you're reducing the amount of sunlight and the amount, therefore, that the Earth is warming up, rainfall is affected in different ways in different parts of the world.
Absolutely, and again, we've spent a lot of time looking at exactly that and publishing papers on that topic.
Well, and what conclusions have you drawn?
The conclusion is it is not exactly equal, just like climate change. So climate change itself, driven by CO2, is not equal. It affects different people, different industries, different parts of the biosphere in different ways, and so too, solar radiation management will not be equal.
I guess the problem could be that if you ended up or a country ended up having a scheme whereby they had solar radiation management over their country, but the effect was that the country next door ended up getting a lot less rainfall, which is one of the feared consequences of this. Then you could almost end up with a cause for conflict.
Yes, I think this is precisely where the sort of hard geopolitical issues arise. I mean, to put it in a kind of crude way, whose hand is on the thermostat? Essentially, the scientists and technocrats, including myself, I guess, are helping to invent a thermostat knob. But it's much easier to invent the knob than to figure out who should be in charge of it in a world with many states.
No, indeed, and I want to come on to the governance, but I want to ask specifically about the science of this, which is how far can you tell whether the effects of solar radiation management are then going to cause perhaps a catastrophic loss of rainfall in a certain part of the world. At the moment, it seems to be hazy, this.
I think it's not as hazy as that. So, using exactly the same climate models as we've used to estimate the problems with CO2 in the atmosphere, the underlying climate problem, we've applied those same models and same techniques to look at this. And the results so far, I have to say, look pretty good. That's why we're paying any attention to it. So, in fact, the results look like for small amounts of SRM, it is remarkably even, more even than we expected, and the benefits in terms of reducing climate impacts are substantial.
Right. I mean, I'm quoting again from one recent study, Nature Geoscience, which suggested that engineered cooling of this sort would lead to a much bigger loss of rainfall in China than in India. That doesn't seem to tally with what you're just saying.
I think we're saying the same thing. I've been authors of a bunch of those studies. I mean, one of the issues is whether you're talking about doing it extreme amount, whether you're talking about doing enough SRM to compensate for all of the CO2 in the atmosphere or doing a little bit, and there's more evidence that doing a little bit would be beneficial than doing a lot. And there's no question that it's unequal, but the inequalities in practice, when you actually look at it numerically, don't appear so far to be that big. But all that folks like I am saying is that we should do more research to find out.
More research. I guess the problem with more research is that the research itself could lend itself to consequences which could be damaging. I mean, if you think about drugs trials, for example,
yeah.
The best drugs trials, by and large, are the ones that are done on the largest scale. If you do something like this on a very large scale, you could be talking about affecting huge swathes of the planet.
Yes, but at least at present, nobody's talking about that. So to me, in the near term, research means research with computer models and research where we test the effects, say, on the ozone layer of very small quantities of these particles, much too small to change the whole climate.
And then, forgive me for interrupting, you say computer models. Isn't one of the problems with the climate and studying the climate is that it's incredibly difficult to know exactly how it works. It is very difficult to model.
Sure, it's impossible to know exactly, but you can still learn a lot.
Fine, but this is at some point going to leap from the computer screen into real life, and that's the point at which there could be danger.
First of all, we need to make a decision to do that. I, at least, am not ready right now to say that we ought to do that. We need to do the other research first. If at some point it actually makes sense to do this, we would presumably start with very tiny amounts of aerosol, an amount less than a big volcano, and we would ramp it up very slowly, watching for ill effects and benefits as we did that over a decade or two. And you would monitor the system, and if you saw problems, you'd stop. That still doesn't guarantee you safety. There is no guarantee of safety here. But remember, the benefits are also large. So one of the most obvious things that we understand about climate impacts is heat stress on crops. A bunch of the poor farmers in the world, the most likely impact they'll see from climate is that the peak temperatures reduce the productivity of crops a lot. And first order models that we've actually run with crop models suggest that SRM could significantly reduce that impact. And that's a big deal for a lot of poor people in this climate.
Given that you're talking about beginning at a relatively small scale, I'm wondering what your reaction is to the postponement of a study here in the United Kingdom. It was the SPICE project, the Stratospheric Particle Injection for Climate Engineering project, which was planning to send a balloon and a hosepipe a kilometre up into the sky as a possible precursor to this type of solar radiation management that you're talking about. That was postponed at short notice for a further 6 months of public consultation because there was a bit of an outcry about it. How did you think that was handled?
I think it's interesting because it's the first real opening up of the public debate. I personally never understood the point of that experiment. So that experiment's sole goal is to find a technocratic way to make it a little cheaper to get materials in the stratosphere. And the one problem we don't have is that this is too expensive. All the problems with SRM are about who controls it and what the environmental risks are, not how much it costs. It's already cheap. So from my point of view, I thought that was a very misguided way to start experimentation.
But my point is not so much the sort of the work of the science, but more about the public outcry about it. I mean, if it was that benign, it must be a cause of concern for you that there was this outcry and a decision to postpone it for 6 months.
My job is to help state the science clearly and help people think about the governance. It's not to promote this. So actually,
it is in part to promote this. I mean, you're a great enthusiast for this, and as you said, you have your own private company, which is...
At my private company, we're focused on a very different part of it, which doesn't suffer from these governance challenges.
But it is all to do with the issue of geoengineering. I mean, you know, it's an incredibly sensitive topic.
I absolutely do, but I actually don't think my job is promoting it. My job is to help clear thinking and clear knowledge about the tools we have to regulate climate risk, among them this one. And I'm perfectly prepared to find that results show that we should never do this.
Well, do you think in that case that the current climate, in terms of the political climate, is overheated, or do you think it's actually fair enough that people might be very concerned about these sorts of experiments?
I think it's healthy that people are concerned. People should be concerned about cheap technologies that can manipulate the entire planet's climate. But don't be so sure which way the public outcry went. So we actually ran a survey almost a year ago now that took data, high-quality data, from 1,000 people in the UK, Canada, and the US to try and understand public support for research on these technologies and what kind of political leanings influence people's decision to be for or against. And in fact, we found pretty broad support for research. So it's not clear that that is changed. What's clear is that some groups have been vocal trying to oppose, and I think it's absolutely reasonable that they should. These are hard topics.
But that particular opinion survey that you're talking about, it also came up with the finding that 64% of subjects agree that humans should not be manipulating nature in the way suggested by solar radiation management.
Exactly.
Well, that would suggest that there isn't particularly broad support at the moment for the theory behind this.
There's not broad support for doing it, and I think that's quite a healthy thing. I mean, I'm one of the people who, maybe starting 20 years ago, most helped to open the door to get public conversation going on this thing. My current fear is that the door will be kicked open and people will rush forward to do it too quickly.